First off, if you have watched the demo, then um, you would have seen sort of an example on how to like kind of kickstart this off. And so I encourage you, if you're like listening to this and watching this simultaneously, you could go ahead and kick off your dev container locally. So like if you've cloned the repo and you've opened it up in VS Code and you've got the code spaces installed and you've got the Docker engine installed, you can reopen the project in dev containers as shown in the docs, or which was another big motivation in this whole affair, is being able to like quick start it and start from code spaces. Um, so we'll just go ahead and do this live then. Um, so what this is using is CodeSpace pre-builds, which is a feature from GitHub that we've got enabled for the organization. And so it's sort of a coupon for FOSS projects that they were allocating out. And what it allows us to do is like pre-build the code space in an action. So if we go over to actions, we can see sort of the history. Here's the job that I kind of kicked off 9 hours ago. It takes quite a while. I'm kind of debugging exactly why the caching isn't working as expected, but this spares you 2 hours and 4 minutes of sitting here and getting it loaded. So what this is doing right now is probably loading all the VS Code browser extensions locally, or over my really crummy internet, and loading from a sort of a pre-built VM from CodeSpaces. That said, I don't want to go over to the live demo just again because you've already seen that. Let me dive into deeper on sort of the layout of the project. So like how people can kind of template this further. I know that the nav2 repo is rather large now, and the sort of the continuous integration pipeline we have sort of set up maybe somewhat intimidating. So to sort of simplify the template, I have sort of replicated everything, the core sort of functionality as a minimum viable example over on this small little sandbox repo. So let me just paste the link here. So this is just something I did yesterday to strip it out. Oof, internet connection. The bummer here is this is prime Netflix time in Italy. I mean, we're at 9:30, so this is when everyone else is streaming. All the other tourists are probably hotspotting on their phone too. So in this repo, which I just called our playground sandbox, it provides sort of the same example. The one kind of difference here is we're not building nav2 from source. We're just installing it using the humble binaries, and it's if you could start here and you could like launch a code space from this as well, and the only difference is it's just going to pull the pre-built image that I have sort of hosted on GitHub container registry, which I'll show you in a little bit. So let's just dive right into the simpler repo. So here we'll have we have our dev container folder, which just follows all the schemas of the dev container standard. We have our GitHub folder for our workflows for building the CI image for this particular case. I'll explain later how that maybe avoids having to need to use CodeSpace prebuilds. We have our VS Code folder, which we'll use for tasks. We have a launch file that I just kind of copied over from the rolling branch of nav2, so we can do our demo headless, because that's not backported into Humble yet. We have some Docker ignore, some Docker file, and all that. So let's jump into the Docker file. Right here, we're just building from Humble, and we're using multi-stages. They aren't strictly necessary in this example, but I just kind of kept them as a template from nav2. And so we're going to install all the ROS dependencies. And so in the demo you saw, I was using AWS RoboMaker World. We're using Foxglove Bridge to bridge to the Foxglove front end. We're using nav2 bring up to just install all of nav2, including the Turtlebot launch files. RViz is probably optional. I don't know why I still had that. And for Humble, I actually had to manually install these two Turtlebot packages because they're not explicitly linked in the dependency tree. The other thing is, if you wanted to take a look on how I reduced this, all you have to do is just look at the pull request 1, where I copied nav2 and then stripped it down. So if you're looking at nav2 to kind of figure out what's important, there's another case example. All right. Then we get to sort of a deliver stage. So I had this imagined as an intermitter stage where you don't necessarily using all your visualizations, but you could change your dev container target to target this if you just wanted to be minimal and have some ergonomics for development, like bash auto completion, pip3, and wget. But we're also going to install glances, which is like a system monitor. So you can use that in the terminal, but we'll also use it in the web. Here's a thing you might not be familiar with, depending on how advanced your web development experience is. This is Caddy. Caddy is a web server. Here, folks, can you go ahead and mute yourself and maybe turn off your web camera, and then that might save my bandwidth a little bit. Thanks, folks. Hope my audio quality improves. So the Caddy project is a web server that's written in Go. It's fairly user-friendly, great documentation. We could basically use it as default. I'm using a custom plugin, a module though, for that I'll explain later, for replacing arbitrary strings in the responses to kind of inject material we need for installable progressive web apps. So we need to actually kind of build it from source, but it's fairly simple. All you do is use the Caddy builder image, use xcaddy, and then pass it which kind of module I want to build it, and it'll build the binary, which we can copy in our final stage, this visualizer stage. And so you should look up on how multi-staging works in Docker, but see here we've built from this particular image, but then we resume back again from the Dever image. So this is basically like a directional acyclic graph that you can kind of build on layers, and it's all in one Docker file. So we set an environment variable that we'll use to be the root of the web server to host all of our progressive web apps and visualizations, and we'll just go ahead and create it. The first thing we'll do also is we'll install all the dependencies necessary for building GZ Web Classic. This is GZ Web for Gazebo Classic. It's a fairly long-lived project. It hasn't changed much recently, but it still works. It just needed some minor patches to sort of get working. So we'll go ahead and clone the repo, and the first thing we kind of do is we kind of set the need to model paths to include all of the models that we wanted to include in the simulation, the AWS world, the Turtlebot, and stuff like that. So here's just a very simple rudimentary script to kind of find all the model folders in the ROS opt folder path. So here's even more hacks. There's a hard-coded list of of models in the GZ web, which I don't bother building all the thumbnails for because it takes so long. And so I just kind of set that to an empty list, so we don't get a whole bunch of 404 errors on missing thumbnails. All right, so to run this, maybe this isn't quite necessary anymore, but if you were like building the thumbnails, you would need to have a frame buffer for it to like launch, I guess, Gazebo and render the image and then shut down, and that's why it kind of takes so long. But we'll just go ahead and build only thing local and not build the thumbnails. And this is compiling the npm project for GZ Web Classic, as well as building the WebSocket bridge for Gazebo. And so it's like kind of binary that then gets loaded into Node that I think GZ Web uses. So here to eventually kind of service, this is another hack. I guess how GZ Web Classic is kind of organizing all the model folders. It expects to have a models folder in the root of the assets, which really just points to, you know, the DA files that would be in the folders in the root assets anyway. So I make this silly recursive link, so that kind of solves that issue. Here are some other hacks I had to do for Humble to resolve. So like Turtlebot keeps its meshes files in the common, where I guess enrolling that was solved. So I had to add this hack to point the redirect there. And then the last thing we do is the HTTPS client kind of folder within the Gazebo web workspace is basically the GZ web folder that we'll use to host on the web server. So we go ahead and make a link in the roots srv GZ web to point to that. All right. The next thing, to run Gazebo headless, I'm guessing there's some other options you could do, but you know what I just simply opted to do is again to use the X-frame buffer. So I just moved the Gazebo binary, made a executable bash script to then execute Gazebo within that frame buffer. So that allows us to run Gazebo headless, Gazebo Classic headless. I think that's improved with the newer version Gazebo, so correct me. All right, and then the last thing here is we need to sort of do the same thing with Foxglove. So we're going to try and get the static files. Foxglove does release their binaries, or they're sort of the Webpack kind of site image. Like if you wanted to run this as self-hosted Foxglove frontend within their like a Docker image. And so again, the same thing, we can just copy the source folder from that Docker image and put it in Foxglove. The reason we have, you know, my fork here is because if you look at the PRs, I needed to modify the I need to add an extra URL param to kind of make it convenient to launch the layout. So like, you know, if you ran Foxglove straight out, it would provide you just the default layout, which doesn't, you know, isn't terribly exciting. It doesn't show the navigation to occupancy map or the any of the sort of routes and goals. So to kind of facilitate that, I went ahead and added that feature and then made a pull request, and we'll see where that goes, but you can read more about it later. We install the caddy binary, and that's just from with the particular module that we have built. Previously, I was just installing caddy from apt until I needed that particular module. But you can install it as a Debian if you don't need that particular feature. And then here's a little bit of bash or a shell that's just downloading the media files. And so you know, we could check in all the icon files into like get LFS, but like if you're in free open source org, I think you only get like 1 GB of storage bandwidth per month, and so ROS planning is a very popular org. I don't know if any other repos are using Git LFS, so I didn't want to have to rely on that. So you can just like upload, a small attachment to a comment, and then just use that anonymous URL, and that's just kind of a workaround that we did here. All right, so that is what builds the image. And so if you were to do Control-Shift-P, Dev Container, rebuild and open a container, that's the Docker file build. I'm just going to open a reopening container. Okay, you can always click on the bottom here and you can get a little log, to see how the sausage is made. I enjoy that because, I look for errors, but it's also kind of handy to figure out, where you are. So the Docker image has already been built, and it's just like, installing the code space, or sorry, the VS Code extensions and stuff like that. Okay, I think it's done. All right, so now you see in the bottom left here, we are in the dev container called Sandbox. Let's go to our dev container JSON file. So as in the nav2 docs, this is sort of a standard thing. So it's not just like a one-off little project like OSRF Rocker, which is like a wrapper around the Docker CLI. This is a fairly larger kind of extensive ecosystem. You can use VS Code with it. See, I can't keep up with the comments, but I'll let you keep chatting in the comments. You can use it with VS Code. You can use it with JetBrains. You can use just this GitHub CLI, or the Dev Container CLI, if you're doing everything headless. So we just specify our name, and here I'm specifying the image. And so here's the image that I kind of built on my repo. And if you wanted to build it, you could also uncomment this and comment out the image. And so what that is doing is we specify, the location of the Docker file, the Docker build context, which is also the root of the repo, what stage we want to build up, so the visualization stage, and we cache from. And so this was what I was hoping was kind of working. I need to debug something. But if you specify the cache from, you can leverage, you can just pull the image, and as long as you haven't broken the Docker build cache by modifying something locally that was in the context. I have this Docker ignore, which ignores just about everything, so it shouldn't happen. That will speed up, the container spawning process, because you basically have all the layers pre-cached if you were to download them. Here are the run args. So, I sort of have small little comments on, what each would be useful for. So, like, if you were developing dev containers in parallel with something that was running, like ROS nodes that were running on your host, and you wanted to sort of seamlessly connect to them, all you'd have to do is just enable network equals host, and you kind of get the host interface attached to the container for free. If you then wanted to do like shared memory transport, well, then you sort of have to like uncomment the IPC, and then if you want to ensure the DDS discovery is working, you would have to uncomment PID host, so that DDS middleware can kind of see, what its own unique ID is, GUID. If you were doing debugging, you might have to set the security options to unconfined. If you wanted USB peripherals, then you might need to use privilege, stuff like that. But this, you can provide just about every Docker argument, Docker run argument here if you needed to. Here's our workspace folder. We're just like specifying what arbitrary path in the container we want to mount our workspace to, or where we're going to launch our VS Code kind of instance, what it defaults to. This is the workspace mount, so I'm just mounting it in the same spot using the dev container environment variables and specifying bind. I've talked to some people, like if you're using Mac or WSL, you might want to check into a different version. Like I guess that's not quite efficient, or it doesn't work if you're mounting file systems from inside into a VM that then's running the Docker engine. That can kind of get complicated. But for Linux, I think the most efficient. So then we have all these various on commands. So in the nav2, we use this to compile the workspace as soon as you start it. So like you could run Dev Container and then walk away and everything's just going to be built automatically. The reason I don't build the project in the image for like nav2 is because our CI doesn't necessarily need that, and we're just kind of we're just dog fooding our CI as well for our cache from image. So that kind of helps people start a Dev Container instance as close or similar as possible to our CI to reduce any friction there. But that would also, if you build the binaries in the image, it would just kind of bloat the image and then slower to download, and you would overload them anyway when you mount your workspace on top of the folder. So not much point there. And then so then customizations, that's very simple. This is just code space specific, open a certain folder, install certain VS Code extensions, blah, blah, blah. Let's go in order. The on create command. This gets run once whenever you spawn a new container. So there's just something I have to do to set a get flag. And I also kind of leverage the update comment command. So this command is like where we have to build, and so we could build the workspace both when you first create the container or if you ever update it. So this is what this script would do, but here I just echoed down because I'm just installing the binaries. Post install command, this gets run once after the container has been created, and so here I'm just adding some more symlinks to our SRV folder relative to our Dev Container SRV folder. And so that's where some PWA specific files live. And so I kind of generalize that here. So if we go to the caddy folder and the SRV, we have the assets folder and the nav2 and their caddy file. At this point, why don't we do Control-Shift-P, and then we do tasks, run tasks, and I have sort of 3 visible tasks here. To stop the visualization, start, and restart it. The reason I have kind of that restart is if you're bringing down the gazebo simulation and bringing it back up, or you're bringing nav2, stuff like GZ Web doesn't gracefully handle disconnects from GZ Server, so you have to restart it. So you can just easily do that there. This is the front end, so it's not necessarily you need to do this here. But if you restart nav2 or the simulation time, Foxglove front end will kind of get confused by the non-causality of time, and the TFs will get weird. So you might have to reload Foxglove there. But let's start this. So this starts the process in the background, the web server, the system monitor, GZ Web Bridge, and Foxglove Bridge. And you would also see sort of a toast icon here saying, oh, you've got some ports. So we can go to the ports, and the most interesting one for us is port 8080. This is we haven't uncommented any of the run commands for like .NET equals host. So this is VS Code that is forwarding the ports automatically for us, not necessarily Docker. So if we click this port, or if we open this in the browser, okay, sorry, but I'm not, my system isn't using port 80, so it just mapped it straight forward. So it looks fairly transparent. But if port 80 was being occupied, it would route it to a different one. So this is the launcher page, or the launcher app for all the other progressive web apps. Let me copy the launch command. So in the README, here is the command to run the demo. We'll open up into terminal. So, Control Shift tilde, or hit the plus button here, and then just Control Shift V. Alright. So that's going to run nav2, and then gzbridge is going to connect to the gz server, and Foxglove is going to start forwarding topics. So if we went to our browser and then hit, so initially you probably want to click on auto layout, and so that's going to open up a Foxglove instance to download the layout initially. So on the layout here, I've downloaded it several times, so I have the duplicates here. But there we go. So we've got the robot running around with the LiDAR and the map here. We can also open up the system monitor, the GZ web client. I could also launch the file browser. So this is, everything in that root SRV folder. I can navigate around. It's kind of handy for debugging to see, whether something's missing from the file server's perspective. GZ web is flaking out. Okay. There's glances. Alright. And so my computer is both recording my screen and running the demo, and it's about 7 years old, so it's crushing. This is another reason why I kind of like using code spaces, is then my computer just has to run the web interface, which is fairly lightweight. My tablet can do that, and then I can offload anything heavy to my desktop using SSH. So you can use okay, I got 10 minutes. So you can remote connect, not just through Dev Containers, but or through code spaces, but all through like SSH to your workstation, and then start the Dev Container there, link to that, and the port forwarding will kind of all just work. So aside from that, I think the most thing that maybe other people aren't familiar with here is the caddy. So it kind of helps to install the caddy language extension to kind of visualize it. So we'll just install that in the container. So it's kind of, you have to remember that, if extension's missing, make sure you install it in the container. But here's the layout of the caddy file. It might help to read it from the bottom up. So here we're listening on any incoming connection on port 8080, and we'll just import a whole bunch of global variables that I have set up above, and we'll set our root to be the root environment variable. But if that's not set, we'll also just default to SRV. We'll start a file browser, and we'll enable the browse feature because that allows you to navigate the file tree if index.html files don't exist. So then we have our handle for a root directory. We're just kind of handling some miscellaneous things for the manifests that are used for the PWAs. So if any request is sent to try and get a manifest.json file in their assets folder, the templates will take over, and so we can start templating our manifests. I'll show you later. We have our handle path for nav2, so that takes anything that's like going to this path into the star, strip the nav2, and we open up the nav2 folder. We set some mobile imports for a snippet, some templates. We have a root redirect, so if you try and open up port 8080 by default, it'll just browse there. Redirect to nav2 by default, which is convenient. Here's the two examples for adding the GZ Web and Foxglove. And so I have a sort of a template on both hosting the app and also doing the proxy redirect for the WebSockets for that all to work, which was a fairly big affair. And then we have also the a reverse proxy for the glances. server, so you can use glances in the browser. On the top here, the globals, they just set some variables that allow me to detect whether the client is connected behind HTTP or HTTPS, because I need to set the WebSocket schema appropriately. I also need to know how the client kind of sees the address, because I use that kind of feature later for templating the manifest file for the PWA to include like the host name, so that the user always knows where they installed the PWA from. And then I have the WebSocket, so like I can capture, if I get an incoming WebSocket connection, I know to redirect it appropriately to the appropriate backend. Here I'm having custom redirects for auto connect and auto layout, so I can feed Foxglove the appropriate URL query parameters. I have a dummy thing because I just needed that kind of dummy template for import for a formulaic template. Here's the mobile. So this is what enables the PWA for mobile devices. And so I'm basically doing, I'm looking for the head and the HTML file, and then I just add the manifest reference link. And I needed to use cross origin because if you wanted to use it behind code spaces, you need to make sure to use your cookies to get that file. And just a handy redirect. So this is you'll have to look at the Caddy's documentation. It's fairly good to kind of really grok the entire bit of it, but I tried to comment every line to make it sensical. Here is the nav2 bit, so the people can just modify the launcher page in straight up Markdown, and then that gets rendered using Caddy's template injected into Markdown, and I have some friendly GitHub Markdown CSS to make it all nice and rendered. Here's the example manifest for nav2. So when I install this on Android, I get the friendly icon, I get the ID, and color theme. For Foxglove, for example, you can do some more stuff. So here I've added shortcuts. So if you were to long press the icon, you can get the auto connect, auto layout, and manual connect feature. The same thing that you got on the launcher page through the web browser. And this is like, setting that kind of full screen allows mobile devices to open the app in a standalone rather than in the browser tab. And then from there, based on the device, you can start multi-windowing, and then you can have just sort of an equivalent, RViz, GZ viewer experience where you have your code aligned with different windows for your visualizations in a sort of a mobile experience. So yeah, I don't know how much time we have more questions, but maybe I can schedule a something standalone if there's interest.
Awesome, yeah. So does anyone have any questions? Yeah, just go ahead and...
Hey Ross, thanks for the presentation. It was really interesting. I guess I just posted my question in the chat. I was wondering, I was wondering if you have thought about just setting up the remote desktop instead of port forwarding, using the browser-based ones to kind of avoid all the network configuration problems that you are showing us how to handle.
Yeah. So if you look at the, I need to finish the visualization documents. But if you look on there, I do explain. I do list some examples like using VNC or screencasts. But I wanted to use the WebViz because it allows me to do like a high refresh rate, I can use my local GPU to render the 3D scene rather than sending frame buffers over the wire. In some pens that can be like better for low bandwidth scenarios because I'm just sending like a laser scan, but for like point clouds that might be worse. So there's certainly trade-offs. but I think it adds to the bit of having a proper experience rather than always remoting into a remote desktop. But there's certainly a trade-off, and the documentation I tried to I'm going to expand that kind of decision matrix to make that clear to folks.
Thanks.
Ask question. Two questions, simple. One, is this nav2 dependent? I assume not. The second question, is this VS Code dependent? I assume yes. And if so, how would you say how difficult or easy to remove the VS Code dependency?
It is not nav2 dependent. The sandbox is an example of just using, installing nav2 from binaries is not critical. I'm just using nav2 as the example use case and to foster contributors. Is VS Code required? No, you could use, like I said, the Dev Container CLI or JetBrains to spawn the dev container. And because I'm not using X forwarding, I'm not using VNC or something, I'm just using ports in your browser, that generalizes. What is maybe specific is the VS Code tasks. That's something here I'll show you to quickly start and stop all of the things, but I mean you could alias that into your own kind of scripts. Steve was telling me like this might be something good to be a launch file, and indeed it might be because of particular managing the life cycles of these processes. Like if I accidentally refresh my browser, VS Code right now doesn't show me previous tasks that are running, so I have to like manually kill them, which is annoying. But it does make it quick when there are tasks showing. It makes it very dead simple to restart and manage the life cycles. So yeah, you could replicate that with any other kind of IDE or something.